You know what sinusoidal graphs actually are. You've been using it all along. You've been using it in trigonometry. So when I say, or you see sinusoidal or sine, we're talking about sine graphs. And you have been seeing the word sine for about 3 years now in trigonometry. Remember, tan, cos, sine. So sine is the only one that we're going to do. We don't have to do graphs for the others. So, brings up our first question, which is the very first point on here. The calculator has to be in something called Radian mode. So first, let's find out where that is. So on your calculator, go ahead, open up your calculator. You should have seen this before, in case you haven't. Your calculator needs to be in Radian mode to do all this stuff. So you turn your calculator on, you click the beautiful word that says mode, and you should find a word that says degree or radian. The first option is radian, the second option is degree. Make sure radian is highlighted. You can do these questions in degree mode, and every once in a while you'll have to do it in degree mode, but for the most part, 99% of the time it's radian. The only time it'll be in degrees is if it specifically is saying degrees. You will see in the question it'll say degrees. It'll say 180 degrees, 360 degrees, or something about degrees. Like I said, 99% of the stuff is all in radian mode. Begs the question, what is a radian? So you don't need to know how to convert radians into degrees or anything like that, which you might hear people talk about. All you need to understand is what a radian is. To know what a radian is, I ask you what a degree is. So what's a degree actually telling you? So if I told you to spin around 360 degrees, you would do a full circle, correct? What if I told you to spin 90 degrees? How far would you spin? You would just go this far, correct? All I'm telling you when I tell you a degree is how far of a circle you're going to move. So if I say to move 360, that's a full circle. If I tell you to move 100 degrees, that's 100 degrees out of 360. A degree is a measurement of a circle. How far around
a circle?
the circle? Yeah.
No, like when you say something it's something degrees, it's like the degrees.
Okay. I don't know, maybe that'd be cool. I'm not sure if someone was that smart. So yeah, when it comes to temperature, it's a little tricky. But degrees are a measure of how far around a circle you're going. That's what a radian also is. It's just another way of measuring things. So it's another way of measuring how far around a circle you need to go. The measurements are a lot stranger. So if you were to do a full circle, you do 2 pi degree or radians. So if you were in Math 20-1 with me last year, we did some of this stuff. We talked about radians versus degrees, and we actually converted between the two. In this class, all you need to understand is that a radian is a measure of how far around the circle you're going to go. A mathematician saw that explanation of what a radian is, they'd probably have a heart attack, because that's a brutal definition, but it's a very layman term definition which helps you understand what's happening. Just for reference sake, 360 degrees equals 2 pi radians. Just for reference. So a full circle is called 2 pi when you talk about radians. Again, you will not have to convert between the two. You really don't need to know radians at all. If you had never heard of the word radian, you probably escaped through this whole class. All right, next thing. What does a sine graph even look like? I mean, we've never really graphed a sine graph before. At least I hope you haven't. If you have, you probably were very confused. If you put your sine graph into your calculator and it's in Radian mode, and you have a window that's set similar to the way that this window is set, that's what your graph looks like. It looks like this crazy wave. So it's going to just keep going around and around and back and forth like that. And it'll keep going forever. That is a sine graph. I'm going to refer to that as your standard sine graph or your basic sine graph. Okay, this is just sine x. Nothing happening to it, no other numbers, just sine x. Some things you'll notice. The scale on this graph is kind of crazy compared to what we're used to. So, if you look at the scale on this graph, the y values only go up to +1 and down to -1. So the y min is -1, and the y max +1. Other things that you're going to notice is kind of crazy is the x values. So the x values, look at their scale. The scale is not standard numbers that you're used to. And the reason why is because we're talking in a basic sine graph, we're talking about radians. So what this is pi divided by 2, that would be 1/4 of a way around a circle. Pi would be halfway around a circle. 3 pi over 2 would be 3/4 of the way around a circle, and 2 pi would be the full circle all the way around. So that's why these x scales are so strange. So their x scale we'll talk about that in a second. We're going to get there. So the x scale is pi over 2. And again, you're really not going to have to do too much with pi's and stuff like that. What we use sine graphs for is situations where you actually do see this. You see this pattern where it goes up, down, up, down, up, down, up, down, up, down.
Dude, you can actually do that in your calculator.
Yeah, and we're going to do it in our calculator. We're going to create cool equations in our calculator. And we use these to signal real-life situations where if you follow a pattern like this pattern has a special name. If something has a cycle, where it repeats itself, we call that a period. This thing cycles. One period is from here to here. So that chunk of the graph would be one period of the graph. And then it repeats itself. And then it repeats itself again. And then it just continually repeats itself. A period is the first thing that we're going to look at. So a period is something that repeats itself. That's what's meant by the term period. Now you know what a period is. So it's just a cycle of something. If you were to look at this thing, boys, the period is highlighted here, and then you'll notice it stops, and then it does repeat again. So this thing would have a period of 2 pi. The reason I know that it has a period of 2 pi, there's 2 ways I know. One is this little midpoint right here, this x-intercept. I find the horizontal distance to the next x-intercept where it's going upwards again. So I would not count that x-intercept because it's going downwards after that one, but I would count this x-intercept because it's going back up. The distance between those 2 points is 2 pi. So if you can find x-intercepts and then find the distance between them, that will tell you your period.
Only if they're both straight.
Yeah, because you're trying to figure out when the graph starts to repeat itself again. It's not repeating itself at the first x-intercept because it's going down at that point. But if you go to the next x-intercept, that's a point that's the same as the first point. It's going up. Another good way to figure out how big it is to find your relative maximums and figure out how far apart they are from each other. These things should also be 2 pi apart from each other. In this case, it's easier to look at the x-intercepts because the first one started at 0. But in other questions, it might be easier to figure out where your maximums are, figure out how far apart they are from each other. You can also figure out how far apart the minimums are from each other. And those would all be 2 pi as well. So those are all different ways of figuring out how far apart the period is. All right, there's a period formula. The period formula is period equals 2 pi divided by b. And that b value is going to become important for us. That b value is going to become part of an equation in a little bit. And you're going to have to solve what b is for. How do I get that? B? Yeah, this, right now, this is out of nowhere. And this formula will be given to you on a test. It'll be part of your formula sheet. For now, it just looks like it's out of nowhere. Because what we're going to be able to do to this graph, the standard graph has a period of 2 pi. We are going to stretch these graphs and compress these graphs, which is going to change what the period looks like. So I might change this period from being every 2 pi, I might change it to be every 20 pi. And that means there's some value that I've multiplied it by. So that value is something we're going to figure out in the future. And this is kind of like a teaser for that. Yeah?
Will the formula always be 2 pi, or will that change?
It'll always be 2 pi. The formula is always going to be this, and it's the only formula you get. So, like for this unit. We will do some questions like that to solve it. Alright.
Did Miss Tux process this?
Yeah. Okay. The second term that you're going to learn is amplitude. And the value that's associated with amplitude is a letter called A. So you're going to hear me refer to it as A. So I'm positive that there's got to be some way to connect amplitude to music. I just don't know enough about amps to know the answer to that. So what amps are to us in math, amps is the distance from the maximum.
It's the distance in music, the
frequency
of the wavelength of the sound that it's making. So if you have like a bass amp, you need to have a bigger frequency of like the waves in the music.
Is it the full distance, or is it just distance?
Because like if you've got like a bass guitar or something,
yeah,
the waves would be a lot bigger and it would blow your speakers. So that's why you see bass amps a little better.
Good.
Also in electricity.
Yeah, I know that too, but it's also has to do with the waves. I know it's something. Okay. Amps is the distance between the maximum and the midline. So you're going to have to be able to find midlines in this. To figure out a midline, you're going to figure out the distance between your maximum and your minimum, and then cut it in two. Right? So you're going to have to figure out midlines. Let's start things off. What is meant by the term amplitude? Amplitude is distance from max or min to the midline. Sometimes, just looking at a question, you're going to be able to know what the midline is. If I look at this question, the midline's at 0, right? It's right across here, y equals 0. Other questions, it's not going to be so obvious. Yeah?
Taking out another practice, or not practice.
Notes?
Notes.
Yeah. Plug it. There is a formula that you can use for amplitude. It won't be given to you. And so that's important. The formula would be max minus min divided by 2. That max minus min, that's figuring out the distance from the maximum to the minimum. So for instance, this thing is all the way up here at, okay, the distance here, my maximum is at positive 1, my minimum is at negative 1. If I wanted to figure out the amplitude of this graph, or the A value, I would go 1 minus negative 1 divided by 2. That would equal 2 divided by 2, which equals The only time that this thing wouldn't work is if this graph was all in the negative values. What you'd end up getting is a negative amplitude. You just have to take the positive answer of it. So this will always tell you the distance from the top to the midline, and you just have to sometimes put it in context. If they give you a negative distance, that's because you're just in the negatives. It's still the positive value of that. So if this formula had come out and said the answer was -1, the answer would actually be +1, because distance from the max to the midline can't be a negative number. That just doesn't make sense. All right, so period. How often something cycles? Amplitude. Distance from the maximum to the midline. Or max minus min divided by 2. Either way, you can figure that out. Either by looking at it and figuring it out, or using the formula. This formula, not given to you. So you'll have to just know that. Alright. The way that we change graphs. So I showed you the standard graph, which was sine x. We actually changed that thing. So we change it by stretching it vertically, and we also change it by compressing it or stretching it horizontally. So those graphs can change quite a bit. We change them by using this. Instead of y equals sine of x, we're going to have y equals a sine b of x. And those numbers, a and b, could change things. A is a vertical stretch. So I took a graph and I now gave it an A value. I took my graph and I stretched it vertically, or smushed it vertically. That's possible as well. My B value is a horizontal stretch. That means I took my standard graph and I either pulled it out or I smushed it. Okay, those are the two things that could happen. Let's look at this graph, these three questions, and see if you can identify what A is for all of them. So in this first graph, what does A equal? A would equal 0.5. Right? It's the number in front of sine. For the second graph, what does A equal? And for the third graph, what would A equal? Awesome. What did we just learn that A is also equal to? A is your amplitude from the slide before. Right? That's why they called it the A value. So when you told me that A equals 0.5, the amplitude equals 0.5. It doesn't tell you where you're close. It doesn't tell you where the maximum is, but it tells you how far away it is from the midline. Right? So that's what it does. It could be somewhere crazy, but it tells you the distance it is away from the middle. So that's exactly what this means. If I were to graph that, the maximum is 0.5 away from the middle point. This second one, that's telling you that the distance between the max and the midline is 3. The third one, this is that situation I said before, where I said you might get a negative A value. This says A equals -2. That doesn't make sense to us. Yeah, you're not going to be -2 away from the middle. You're just going to take the positive version of it. So the amplitude for this one is just positive. Amplitude is distance. You wouldn't have a negative distance.
So would that just be like the minimum value?
would be like distance from the middle down. You can think of it like that. Yeah, that would work. What the negative does is it actually flips the graph upside down. But because the graph is the exact same upside down or not, that's why it doesn't really make a difference in the distance.
Does your negative 2 positive?
That's also doesn't matter. We're going to also take the positive version of that. Okay. Now, we're going to look at all these graphs again. And we're going to figure what the b value is for each of them. So for this one, the b value equals 3. It's the number that's attached to the x. For the second one, the b value equals 6. And for c, the b value equals -2. Yep, for sure. Now, what did we just learn that talked about a b value? Yeah, we're going to have to divide. The b value was in our period formula. That just seemed random. So, if you take this period formula, and you know the b value, you can figure out the period of each one of those graphs. So if we fast forward back to where we are right now, and I was to say, what's the period of this first graph? Well, instead of graphing it, trying to figure out the distance along, you can use your formula. Your formula said period will equal 2 pi divided by 3. That means this graph will start to repeat itself every 2 pi divided by 3. That's the formula. So just in case you're flipping your page back and forth over and over, period equals 2 pi divided by 3. So you take that b value, you just put it underneath 2 pi, and now you know how often that graph is going to repeat itself. Every 2 pi divided by 3. Yeah, I definitely meant to put b. I think I said b. And I wrote 3. I do that a lot. So for this second one, if I was to ask you, what's the period of that thing? How often does it repeat itself? You would say that the period equals 2 pi divided by 6. You could put that in your calculator, by the way. Like, you could actually turn that into a whole number, or it would be a crazy decimal, it would not be a whole number, and that would tell you how often something repeats itself. Our last one has that negative in it again. So this thing, if you want to figure out the period, you go 2 pi divide by, and when I divide by -2, no, because that's going to make it a negative number, and it doesn't make sense that something will repeat itself every negative whatever time or whatever talking about. So instead of doing -2, you would just say positive. Again, these things do simplify. This thing would simplify to be pi divided by 3. And this thing would simplify to be pi. Right? The numbers, the coefficients can simplify nicely. Okay, what we... Yeah.
So basically,
the top number is always 2 pi, because that's right out of the formula.
and then the bottom number is the x value.
The bottom value is the b value. Yeah, yeah. The b, yeah. If you look at our standard graph, which is this guy right here, what we have done to it is we have changed the amplitude by adding an a value. The amplitude was the distance from the max to the midline. That means they took this graph, and am I able to see if I can do something? I'm not able to.
Which one is it?
Yeah, well, I
Isn't
didn't
it
want
the
to.
green one?
I can extend it that way, but I can't go one way. I want to be able to just go this. Anyways, we've taken that graph and we've changed the amplitude. We did that by doing a vertical stretch. And the a value does vertical stretches. We could also change the amplitude by compressing it and making the amplitude smaller. The B value took this graph, it stretched it that way and made the period longer. Or the B value could have compressed it and made the period smaller. So you see how these vertical stretches change things, right? Changes the amplitude, makes it bigger, makes it smaller, or changes the period, makes it longer, makes it shorter. For A, it's that simple. For B, it's the opposite. Because remember, you're going 2 pi divided by B. So a big B value would make your period smaller because you're dividing by a big number. By a small number, you'd make your period larger because you'd be dividing by a small number.
By changing like the horizontal stuff, that change your line and your line axis.
Yeah, it'll change all your points except for your x-intercepts. Yeah. All right. Again, remember, it doesn't change. It doesn't tell you where things are. It tells you distances. That's what amplitude and period are telling you. Here's a graph. It's a little blurry. I understand that. I want you to try to state the amplitude and the period for this graph. Okay, so on your own, I want you to try to figure out what amplitude is equal to, what period is equal to. I'm not asking you what your B value is, I'm asking you what's the actual period of that graph. So looking at it, how often does that thing repeat? Amplitude, distance from the top to the middle. If I look at this thing, the top is at 3, the bottom is at -3. That means my middle is at 0. Right? That just kind of makes sense. That means the amplitude would be 1, 2, 3. The distance from the top to the middle would be 3. Another way you could have done it was using that max minus min divided by 2 formula. Would have worked. Yep.
Is what equal to what? Is that x?
It's hard to read, isn't it? So, period. To figure out the period, you definitely need to know what the x they're going up by, which is hard. That is pi divided by 2. That's pi. And that's 3 pi divided by 2. So it's going up by ½ pi every time. To figure out what your period is, you need to figure out when it starts repeating itself. One good way to do that is to find an x-intercept and find another x-intercept that has the same behavior as the other one. So this first one was going up, so I need to find another one that's going up, which is what I did. And you want to find the x value, so the distance between these two guys. The distance between those two guys is pi. So my period equals pi.
So you just basically
Yeah, I would go pi minus 0, and that would help. That would do it for me. I'm just finding the distance between two things. And you can pick any 2 spots where the graph is repeating itself. X-intercepts are just easy to find on our calculators usually. And they're easy to calculate because I can just look at the x values. This is 0, this is pi. I could have also said, all right, what's the distance between this and this? That's a heck of a lot harder because I don't know the x values of those things. Yep.
start with positives because you don't name it.
You can get negatives if you want it, but just know you need to change your period to a positive number. Because you wouldn't say it repeats itself every negative pi times. That just sounds crazy. It would repeat itself every pi. Does that make sense? Yeah. Okay. Now figuring out the A and the B values. So if I wanted to make this graph, I would need to be able to write it into this equation. So I need to figure what A equals, what B equals. What A equals is easy. What's A always equal? The same thing as H. Amplitude. amplitude. So A is just 3. That one's easier. If you can figure out the amplitude, you can figure out your A value. To figure out your B value, you're going to have to rearrange your period formula a little bit. So I'm going to write it up here for you. So period equals 2 pi divided by B. I can rearrange that thing to say B equals 2 pi divided by period. You won't be given the second formula. You need to be able to do that on your own. So B equals 2 pi over the period. That means it equals 2 pi over pi, which means it equals 2. So your A value equals 3. Your B value equals 2. Now you can actually build this equation. The equation is 3 sine 2x. Yeah, y equals. You should say. If you wanted to graph it, that's what you would graph. Y equals 3 sine 2x. Feeling good? Amplitude and period. I think those are the harder two, to be honest. The period's probably the hardest one, because you actually have to do some calculations with it. All right. Other ways graphs can change. So at this point, all we've been doing is we've been stretching it. Maybe we've been stretching it width-wise or vertical-wise, and we've also been compressing it. You could also take a graph and move it. So for instance, if I take this graph, which I'm going to draw on top of it, it's not bad. I got better as went on. I can move this thing. I call it translating. You might have heard that term before. This says shift the graph pi divided by 2 to the left. That would also be known as a horizontal translation. If you're moving it left or right, that's a horizontal translation. So if I want to move this thing left or right, I want to go pi over 2 to the left. What I do is I take a nice little x-intercept. I think that's the easiest thing to move. And I make that x-intercept go from 0 to pi over 2. And I'm just going to move my graph so that it looks like that. Now my graph has shifted pi over 2 to the left. And you'll notice every point moved when I did that. So shifting things moves every single point pi over 2 to the left. It moved my maximum pi over 2 to the left. Moved my minimum pi over 2 to the left.
So
It moved any random point pi over 2 to the left.
we draw this down.
You can draw it if you want. You can sketch it, yeah.
It just moves. Every point moves pi over 2.
Correct.
If it was like 3, it would have
Yeah, so if I said shift it pi over 6, I would now be pi to the 6th left. And every point moves like that. They all move together. This is what the graph would look like if I was to shift it. And this is just an example of pi over 2 to the left. We call it a horizontal translation. We can also do vertical translations. So if we do this one over here, it says shift the graph 1 unit down. Well, if I want to shift it 1 unit down, I'm going to take, again, some point, and I'm going to move it 1 down. I'm going to show you how to do this graph nicely and sketch it, like if I was you and I had to sketch this thing. You'll notice that the standard graph has some points dotted on it. It has x-intercepts pointed on it, and it also has maximums and minimums pointed on If you know those points, and that's why they're dotted there, it's easy to trace it. So if you're trying to trace this thing and draw it 1 unit down, move each one of those points 1 unit down. And that'll make your life really easy to draw. So I'm going to take this, and I'm going to move it 1 down, so now it's here. Now it's here. I'm going to take this maximum, I'm going to move it 1 full unit down. I'm going to take this other x-intercept and move it 1 down, and now it's there. This minimum point, 1 unit down, and now it's about there. This x-intercept, 1 unit down, now it's about there. And what you've done is created like a nice little connected dots. And that's just a nice way to try to sketch it easily. So if you're trying to sketch by hand, it can be kind of tough. Every point on the graph moved 1 unit down. If I take my blue graph, 1 unit down. I did not go far enough. I went too far. Something important to know. Oh, sorry, I'm going to say this is a vertical translation. I just want to write it down, so you write down vertical translation. Something I want noted that is important. When you do vertical translations and horizontal translations, everything moves. Everything. The maximums move, the x-intercepts move, the y-intercepts move, and most importantly, the midline also moves. When you're talking about amplitudes and periods, your A and your B value, not everything moves. Only your maximums and minimums are changing their distance to the midline, but the midline actually never moves when you're doing those stretches. No matter how far I stretch something like this, the middle is always still going to be the middle. No matter how hard I stretch something like this, the middle is still the middle. It's just getting further away from the middle or closer to the middle.
Midline moves.
Midline moves in these things. The midline actually doesn't move in the horizontal translation. It would still be in the middle. Yeah, it's in the middle. But vertical translation moves the middle. So if you get used to working with the midline, which I hope you do, when you're all going to find out a strategy that works for you and how you like to count things out. My advice is if you look at the midline, it really helps stretch things and figure things out. But know that the vertical translation can affect that. All right, looking at this question. When performing a vertical phase shift, shift is the same thing as saying translation. What changes on the graph below? Perform a vertical phase shift of 1 unit up and investigate. So this is exactly what I was just talking about. I want you to try to translate all these 1 unit up and then see if these things change. So if I look at this, I move everything 1 unit up, I'm going to be here. If I was to graph this thing like that, I can keep going, right, if I wanted to. And I ask myself, what has changed? Has the amplitude changed? Is my distance from my top to my middle different? It used to be 1. Now it's still equal to 1. It hasn't changed. So has the amplitude changed? No. What about the period? Has the period changed? Will this thing still repeat itself just as often as it used to? It used to repeat itself every 2 pi. it still will repeat itself every 2 pi. The period has not changed. What is a midline? Sorry, for some reason it goes on to the next line. It's not supposed to. What has changed is the midline has changed. If you were to look at that original graph, there was a line that you could have drawn right through the middle of it. It would have cut that graph perfectly in half. No, everything does, like, all the points change. The period and the amplitude don't change. But all the points move, including this thing called a midline. So this midline used to be at y equals 0. If I was to figure out where the midline is now, I would draw it right here. That's cutting this blue graph.
Which you just moved it up 1, 2.
And now it's equal to y equals 1. So vertical translations tell you what your midline is. If I tell you you had a vertical translation of 10, your midline is 10. Because vertical translations are the only thing that change your midline. So your vertical translation equals your midline. It's the same thing. That's how you can figure out how far a graph has moved up or down. Find out where your midline is. And when we do a whole lot of changes, because we're gonna start changing things a lot. We're gonna stretch them and then move them and then stretch them again and move them again. Being able to figure out how much they moved up and down can be really hard. You do that by knowing that the midline went from 0 to wherever the new midline is. And you might want to write something or note to yourself that the midline equals vertical shift or translation. Both are proper. How this looks in your equation. Your equation now looks like this. So we can add 2 new things to it. We can add our C, we can add our D value. It says there in your notes, it'll tell you your C is your horizontal movement and your D is your vertical movement. So if I look at the first graph, what value is C? C equals 2. D also equals 2. C and D. If I looked at my second graph, C equals -1. D equals -0.5. If I look at my last one, C does not equal 4. This thing is x plus C. That thing has a value in front of x. You need to change that to just be x. You can change it by factoring it. So it looks like that. Now I have an x plus C all by itself. So it's important that you always get x by itself when you're doing these things. Make sure there's no number attached to it. So this thing would say C equals 2, D equals 2. C. For those 3 graphs, if I said C equals 2, that means you had a horizontal shift of 2. C tells you how far something's moved to the left or right. Good question. Would this be left or right?
Right.
Positive equals right. Negative equals left. our t value tells you if you had a vertical shift. This thing had a vertical shift of 2. So did that move up 2 or down 2? Up 2. So positive equals up, negative equals down. Yeah, the D value tells you. It does say that in your notes. It says vertical phase shifts are known as our D value. All right, for B and C, I want you to write if you went left, right, up, or down, and how much. So for each one of those right beside it, say left or right, say if it went how far away. And then say up or down, and how far away. And if you're feeling really good, there's a picture one. I want you to figure out the C and the D value for the picture as well. Try to figure out how far it's gone left or right. Try to figure out how far it's gone up or down. And just approximate. So, because the values are tough to read. So just try to approximate how far left or right it's gone. Okay, for the picture, if I want to figure out how far it's gone left or right, and I know there's been no stretches, that's important, then I can figure out how far the peaks have gone over from each other. So they've gone 1 unit, which is 0.02. So to figure that out, you went from 0 to 0.1. So you figure out what each one of these blocks is worth. Each one is worth 0.02. You get that by doing 0.1 divided by 5, because there's 5 blocks there. You won't have to ever do that with crazy decimals like that, but just in case you're wondering how I did that. Each one is 0.02. So that means C equals 0.02. To figure out D, because I know that there's no stretches on it, I can count any points and figure out how far up or down they go. But the best way to figure out D, what is D also equal to? The change in your midline. So if you can figure out where the original midline is, and now you can figure out where the new midline is, figure out the distance between those two points. But for this question, it's easy enough. I can just go from one point to the other and figure out how far it's gone down. That thing is hard to tell. I'm going to say it's gone down probably like 1. Say probably 1. This is 5. So this is a little bit below 5, like 4, and this is a little bit below that, like 3. We'll just round it. We'll say 1. The gap between that will be 1. You might be 1, 2, 3, 4, 5. Oh. Just say it's 1. I'm figuring out the distance that something has gone up or down. So I found 2 similar points. The maximums or the minimums are good similar points. Figure out how much they do. Okay, I think we're going to stop right here and review this tomorrow.